Hi guys, this is Miss Andrews. We are working on finding inverses algebraically today. So we're going to start with what we did last section, which was 6a1, finding inverses graphically. So to find an inverse graphically, basically start with your original equation, which we have here, the y equals x squared minus 4. So that is a parabola with an HK, or a locator point or vertex, of 0, negative 4. So I'm going to start with graphing that one, 0, negative 4. Then parabolas have the same general setup, assuming that the a value is 1. So they go out 1 and up 1 in both directions, out 1 and up 3, out 1 and up 5. Whoops, wrong spot. So that's my original. Also known as f of x. So what I'm going to do is I'm going to make just a real short xy table. And I'm going to go with just a couple of points. So that one, that one, that one, that one, and that one. So over here we've got negative 2, 0. Down we've got negative 1, negative 3, and then we've got 0, negative 4. And then we go back up, we have 1, negative 3, and 2, 0. Yeah, I put those all in the right spot. So to find the inverse, basically what I need to do is switch all of those values. It still stays xy, but I'm changing the values. So that one, negative 2, 0, becomes 0, negative 2. Any negatives that are with a number need to stay with that number. The next one's going to be negative 3, negative 1, negative 4, 0, negative 3, 1, and 0, 2. And then I'm going to graph all of those. So 0, negative 2, negative 3, negative 1, negative 4, 0, negative 3, positive 1, and 0, 2. So essentially what's happening here is I turn the entire thing on its side. And a couple things that I want you to note, because there wasn't a video for 6-1, it was more investigation, so there's not a lot for me to teach you with these. This is not a rotation. This is more of a reflection, and that's being reflected across the y equals x line. It's that diagonal line that goes across the middle. That's where anytime you have an inverse and it's original, the places where they cross are going to be on that line if you've done everything correctly. So that's graphing inverses. You're just switching x and y. So that's the yellow line. So the line of symmetry, you can't see this, but I'm turning my iPad sideways, so it's not very helpful. This line, basically everything is exactly the same on both sides of it. So you got this little kind of heart shape, upside down heart shape, or sideways heart shape. So basically everything, if I were to fold it along this line, would match up perfectly. So that's that line. Similarly, some of the things you may need to know, you may need your parent graph toolkit. Depending on how comfortable you are with that. You may need, you need to remember to switch x and y. And also keep in mind negatives stay with the numbers. And then your inverse and the original should have a line of symmetry. And I'll go back and explain that in a second. At y equals x. Symmetry. Okay, inverse operations, to remind you of some of those, we've got addition and subtraction, multiplication and division, square and square root, cube and cube root. I'm going to pause and write all this down so it doesn't take it that much time. Okay, so essentially to undo any of these operations, if things are being added, you're going to undo them by subtracting. If they're being multiplied, you're going to undo that by dividing. Squares are going to be undone by a square root. A cube is cube root. If you're not sure about this, the cube root on the calculator, that can be done by doing, for example, x, and you would put a number in there because x won't work in your calculator, to the power of parentheses 1 divided by 3. So there's also a cube root function, but that fractional power will always work if you don't have a graphing calculator. All right, so quick review of the order of operations, parentheses. So anytime you see the parentheses, those need to be done first. This is when we're evaluating. Exponents, and that includes square roots, cube roots, any kind of roots show you guys where I am. Those need to be done next. Then multiplication and division, whichever comes first, left to right. What I have up here, this explanation, is if I have something like x squared plus 5 over 3x minus 8, and I just made those numbers up. When I was referring to the grouping stuff here, we deal with all the stuff on the top and then all the stuff on the bottom, and then the very last thing that we're going to do in this kind of case is divide the top by the bottom. So it's important to remember that those kind of rational expressions can throw that order of operations off a little bit. Basically do the order of operations twice and then divide. And then it's addition and subtraction for your last one, going left to right. And one of the things to remember is when you're doing inverses, to evaluate, you go down this order. And in general, it's not always going to work this way, but it often does. To solve, you're going to go backwards. So you're going to get rid of all these things. Get rid of the multiplication and the addition and subtraction. Then get rid of the multiplication and division. Then get rid of the exponents. Then get rid of the parentheses or grouping symbols. And depending on what's in those parentheses or grouping symbols, you might have to start back down at the bottom again. Okay, so the notes for finding and verifying inverses algebraically. First thing, make sure we know that f of x is the same thing as y, so we can take that out and put y. Step 1, switch x and y. So I'm going to write this as x equals -2 y plus 6 all divided by 4. So then after that, step 2, and this is a rather long step, solve the equation for y. So this is by doing all these inverse steps that we're going to do. So we're in this situation where everything is divided by 4, so that's the first thing I want to get rid of. So I'm going to take 4 and screw up the page. I'm going to multiply the entire thing by 4. So I've got 4 times x equals -2y plus 6. Multiply that side by 4, and the reason I'm doing that is to get rid of it. So what I have on the left, 4x equals -2y plus 6. And then I need to get rid of that 6, so I'm going to subtract 6. Keep in mind, 4x and 6 are not like terms, so I can't combine them. I can't write that as like -2x because that's not what it is. I'm just going to write it out as 4x minus 6, and then equals -2y. Last thing I need to get rid of, so I'm going to divide both sides by -2. And when I do that, I need to divide everything by it. So I can leave this just like this. And in some cases, it's much easier to leave it so that it's not simplified, because simplifying ends up with some really unpleasant fractions. In this case, however, these are both 4x and -6 are both divisible by -2. So then I'm going to go ahead and simplify that. Negative 4x divided by negative 2, positive 4x divided by negative 2 is negative 2x. And my pencil went all nuts, so negative 2x. And then negative 6 divided by negative 2 is positive 3. And then my third step is going to be to rewrite in function notation. And that is f to the negative 1. Just looks like an exponent, but it's really just the notation for inverse. It's negative 2x plus 3. Now, this next part that I'm going to show you is verification. The verification piece, we're not going to work on for A6 or 6A2. We're going to be doing more of it in 6A3, but I want all these notes to be together. The fourth step is to verify. And I'll show you more than one method of doing it, but today we're just going to do the one. So what I'm going to do here is, first part is pick a number and this can be any number that's in the domain of your function, but some numbers will work better than others. To plug in for x in the original function. And it can actually go into the inverse first, it really doesn't matter. So my original function was negative 2x plus 6 divided by 4. And just to be proper about this, we'll write that as f of x. So what I'm going to do is I'm going to go ahead and choose x equals 5. So I'm going to do f of 5 equals negative 2 times 5 plus 6 over 4. So then I just evaluate. Negative 10 plus 6 over 4. That equals negative 4 over 4, which equals negative 1. Then I'm going to take that number. So take the resulting value and plug it into your inverse. So my inverse was negative 2x plus 3. So f negative 1, and I'm going to take this negative 1, put it there. So the inverse of negative 1, and I just totally forgot what it was, negative 2x plus 3, sorry. So negative 2 times negative 1 plus 3. So that is 2 plus 3, which equals 5. Now, let's shrink that down a little bit. If your inverse is correct, this number that you started with should be the same number. So you take any number that's in the domain of your function and plug it in for x. So I chose 5, put it in for x there, evaluate it, and got negative 1. I then took the negative 1, put it into my inverse, and I ended up with 5. So if these two are the same, then you're good to go, and that's verifying your inverse. Negative 2, God. Second method, which a lot of people tend to prefer, has to do with listing the steps that are happening to x, the things that are happening to x, and then reversing them and reversing the order. So what I'm going to do first is I'm going to start with, I've got my x. First thing happening to it is it's being multiplied by negative 2. I don't want to be in blue. The next thing, after we multiply by 2, is we add 6. And then all divided by 4. So we divide by 4. So we're going to do the inverse. We're going to list the inverse of all of those steps. So multiplying by -2, the inverse of that would be dividing by -2. Adding 6, we're going to subtract 6. And dividing by 4, we're going to multiply by 4. So then we also need to reverse the order. So instead of going down, this was the original order, we're going to go from bottom to top. So we start with, for our inverse, we start with our x. And the first thing we're going to do, multiply by 4. So 4x. We are going to subtract 6, minus 6, and then divide by -2, divide by -2. That is our unsimplified inverse, which simplifies to -2x, plus 3. So that is another way to get the inverse. A lot of people prefer it. Either way, you need to show me steps. So make sure that in your process, whichever process it happens to be, you're showing your steps. And then from there, you would verify just the same as before. So that is finding and verifying inverses algebraically. Next class on 6A3, we're going to do more work with different ways of verifying them. And that's it. Have a great day.